Alright, greetings AP Chemistry. This is Mr. Harper live from Galt, California with help for your homework. So what I wanted to do really quick is videotape these solutions to one of your problems off the assignment and put it on the Facebook page so you all can view it and aid yourselves with the homework. So what I want to look at here is number 16 off the homework assignment out of chapter 18. This is one of the problems that I chopped off the assignment originally, but because we're going to correct the other ones, you can look at this one for reference and use it as your guide for number 15 and the other ones that are on the assignment. So the question number 16 is, you require 36.78 milliliters of 0.015 or 0.0105 molar hydrochloric acid to reach the equivalence point of the titration of 25 milliliters of aqueous ammonia. Okay guys, well since like I always say with an acid-based problem, the first thing we want to do is write the reaction. So in the first step of this problem, what you're doing is you're going to be reacting hydrochloric acid, which is HCl, okay, with ammonia, NH3, okay, to give the products, of course, as you remember back, and this is an acid, it's going to transfer proton here to the ammonia, so we're going to get ammonium ion, NH4+, plus, and then, of course, plus Cl-. Now, like I always like to do, though, I like to keep the net ionic equation in mind because that's all that really matters. And so what we've got really here is we have an H plus ion coming to the ammonia molecule, and these of course are all aqueous. I'm just going to neglect to show the aqueous symbol. Okay, going to ammonium ion. Okay, now when it is reaching the equivalence point, what that means is that we're adding equimolar amounts of H plus ions and ammonia. Okay, so equal number of moles, and these are going to be converted entirely to ammonium ion in the reaction because HCl is a strong acid, and this first part is going to go 100% to completion. Okay, now what the problem is asking us to find, what we actually have to do is asking what are the concentrations of H3O+, hydroxide, and ammonium ion at the equivalence point, and what is the pH of the solution at the equivalence point, and what was the concentration of ammonia in the original ammonia solutions. There's a whole lot of stuff in there that we've got to figure out. Okay, so the first thing, we should probably do is to go about finding, well, what is the concentration of the ammonia in our original solution? So what is the concentration of ammonia? This is going to be the easiest thing for you guys to figure out. Well, to figure out the concentration of ammonia, what you basically have to understand is that these can be different concentrations, but we know how much of this it took to react fully with the ammonia. We can do this by stoichiometry, but I think the easiest way to do this is using our favorite equation, M1V1 equals M2V2. Okay, M1V1 is equal to M2V2. We're going to call M1 and V1 here, this is going to be for our acid, and this one here is going to be for our base, which in this case is ammonia. We want to solve for the molarity here of the ammonia, so that's going to be M2, so we're going to just say M2 is equal to M1 times V1 over V2, plug in our numbers here. Okay, if we have M1 of the acid is 0.0105 molar, this will be times the volume it takes to titrate the solution, which is 36.7, sorry, it's a little bit small, but you guys can read it, 36.78 milliliters, okay, but the milliliters are going to cancel out, okay, divided by the volume of ammonia that we started with, which is 25.0 milliliters. Milliliters, of course, need to cancel out. We are left with molarity, which is what we want for concentration, so the molarity of ammonia is going to be, let us take out our calculators, and everybody calculate this with me, make sure Mr. Harper isn't making a mistake. We're going to have 0.0105 times 36.78 divided by 25, okay, and we get, according to Mr. Harper, 0.015 molar. Okay, so there we go. So actually the ammonia is a little bit more concentrated here. If we do this to, actually how many sig figs we got? We've got 3 sig figs. We can toss another digit on there, 154 molar. That is the concentration of the ammonia. Okay. So that's what we're able to figure out by the titration. We know that's the concentration of the ammonia. Okay, now for everything else, we want to find the pH, we want to find concentration of hydronium, concentration of hydroxide, and concentration of the ammonium ion at equilibrium. That's going to require a couple other steps, okay? One of them is going to be an ice table. Okay, so let's erase this part here so we have some space on our board. And the next part is sort of the tricky part. Now remember in class, everybody's kind of, wondering, well, why do you write a couple different reactions down, Mr. Harper? Well, the reason why is because it helps me visualize what's going on. If you think about this problem, the first step is the titration of the aqueous ammonia solution, in which all of this gets converted to ammonium ion, okay, because this is a strong acid. Well, in the course of the reaction, we see that we're making the ammonium ion here. That baby there is an acid. So we're producing a weak acid in the reaction. So when this is made, the resulting solution, as you can probably predict, is going to be acidic, because this further reacts with water, okay? We get our ammonium ion. This is going to further react with water. Again, it's going to come to equilibrium. This is going to create some hydronium ions, H3O+, and then we're going to get ammonia back, okay?